Right, in your packet, you want to turn to where you see this graphing calculator, how to graph linear functions. You're going to need to look at the graphing calculator while I do this. If you are in my room watching, or if you are at home, you can copy all this down and try it when you get back to school. First and foremost, when you have a graphing calculator and you start wanting to plug things in case people are messing with the settings, you want to reset your calculator. So you want to go second, hit the plus, then the 7, 1, 2, and enter. And it should say it's cleared, and that will take it back to all the default settings for you. Okay? So the first thing we're going to do is we're going to identify some buttons that we're going to use, where they are and what they do. The first one is the y equals button, and it's this button right here. It's yellow, top left. It's labeled number 1 on here, and it is where you plug in equations. So if I press that, you can see there's a bunch of y's because you can type in multiple equations, but it'll already have y equals for you. The next one is this x, t, theta, n button. It's over here. It's right next to the green button on your calculator. And what that is a shortcut for an X, because you can type in letters using that green alpha button, and it would take 2 buttons if you wanted to press an X or do the X. This way, you only have to press 1 button to get the X. So it's a shortcut for an X. So if I have this and I press that button, see how it comes up with an X? I'll clear that out. The next one is a graph, and the graph button, first, if you have something that won't clear, see how there's a quit on the blue, you'll hit second mode and that will clear it for you. The graph button is in the upper right. And if there's nothing typed in, there won't be any graphs graphed on there. It'll just be the coordinate grid. And it defaults to 10 with a scale of 1. So it's counting by ones and it goes up to 10. This goes to -10, goes up to 10, and down to -10 here, counting by ones. So the graph button graphs the equation you type in. And we'll be doing that in just a moment. We'll use the trace button after we start graphing some. I'll just tell you what it is now. It gives a point with x and y values. The trace button is next to the graph button on the calculator, the yellow one. The table shows all the values of the equation in table format. So if I hit, let me clear that out, if I hit second graph, it is a table, and if I type in an equation, it will automatically give you all of the y's. So these are the x's, and then it will automatically give you the y's, unlike in 8.2 where we typed in our own, or we wrote in, I should say, our own x's, and then solved it, and then wrote our own y's. This will do it for you. So this will show all values of the equation in table format. Okay. And before we start, I just want to remind you of our equation. This is our slope-intercept form. So before we talked about the m being the rate, well, the rate is also called the slope of a line and its steepness, right? So m is the slope and b is the y-intercept where it crosses the y. So if your equation is in this form, you can easily pick out what number is the slope, and you can pick out what number is the y-intercept. So we're going to practice graphing on the graphing calculator, and we're going to graph 2 equations. okay, over here and over here, and we're going to talk about what we notice about the graph. So the first thing we need to do is go up to that y equals, and we're going to type in 2x plus 2, remember using this button here for the x. So I'm going to type in 2, then that button next to the green one for the x, plus 2, okay? Arrow down so you can do the next one. You can do them both in the same one. We're doing this time 2x minus 2. At any point, if you need to pause to get caught up, if you're doing this with me, make sure you pause. All right, when we're done, we will hit the graph button. And because these ones are colored, the color of the little box next to the y will be the color of the graph. So the first one was blue, the second one was red. Okay? If I hit the trace button, it will pop up on the first one and you can see which equation it was, and it always seems to pop up on the y-intercept. So x is 0 and y is 2. If you arrow down, it will then jump to the other line and it will show you the equation 2x minus 2, and this is where it crosses the y-axis at 0, negative 2. So what do we notice about these? We're going to sketch it. Oops. And the one was at 0, 2, the other one was at 0, negative 2, and you notice that these are parallel lines. So I'll make them as parallel as I can. It's just a sketch. These are parallel lines. So if you look at the equation, what do you notice? I notice that the 2x is the same in both, but this one crossed at 2, this one crossed at negative 2. Why would that be? Well, remember that plus b is where the y-intercept is, so that's where it crosses the y. So if I have a plus 2, did it cross at 2? Yes. If I have a minus 2, did it cross at negative 2? Yes. If they have the same slope, they will be parallel. So what do we notice? They are parallel. One crosses at 0, 2, the other at 0, negative 2. Okay? Let's try a couple more. We'll hit clear and go to y equal, and we have to hit clear for each one to clear them out. So now we're going to type in 3x plus 1 and negative 3x plus 1. So I got 3x plus 1, arrow down. Now the negative, remember, is this button down at the bottom. Don't try and use a minus for it because it won't work. So negative 3x plus 1. So the only difference in these two I see is that 3 is positive and the other is negative. So let's hit graph and see what that does to the graph. All right, they intersect. They both intersect. If I hit trace right there, they both intersect at 0, 1. They cross at the same place on the y. I would expect that because they both had a plus 1, right? They both should be crossing the y at plus 1. Now my lines go in opposite directions, but they appear to have the same steepness. So that negative, all that does is change the direction of the line. The positive one was the blue one. The negative one was the red one. It's going downward. So it looks like the positive one goes upward from left to right, and the negative number goes downward from left to right. So I'm going to sketch it. Here's my point at 0, 1. And I'll just try to make them look like they're the same slope, just to give an idea. And then what do we say? These ones, they intersect. Both cross y at 0, 1, and they seem to have the same steepness. They seem to have the same steepness, just going in opposite directions. Okay. Flip it over. We're going to graph some more, and then we'll talk about where the table part is. So we're going to graph 4x plus 1. We're going to hit y equals and clear everything out. And then we're going to type in 4x plus 1, and we're going to hit graph. We're going to sketch the graph. Okay, so if I hit trace, that's a good place for sketching, to know where it crosses the y. At least when we sketch, it crosses at 0, 1. So it's 0, 1, and this one's a little steeper than the other ones were, so we'll sketch it out like that. This is my y-intercept, right? 0, 1. This is my y-intercept, right? So here is my slope. Here is my b, or my y-intercept. My y-intercept crossed at 0, 1. Here's the positive 1. Okay, so we're making some connections there. All right, now I'm going to go second table because I want to show you how it fills in the table of the values in there. We're going to start at 0, and we'll just write some of them. We'll go down to like 3. So if you plugged in x, or 0 for x here, you would do 0 plus 1 is 1. Did you get 1 here? Yep. And then on the next one, if you plugged in 4 times 1 plus 1, 4 times 1 is 4 plus 1 is 5. Did I get 5? Yes. So it's doing the math for you where we did it before by hand. So 0, 1, 1, 5, 2, 9, 3, 13. Okay. In the table, because these are like ordered pairs, in the table, this is my y-intercept because that's where x is 0. That's my y-intercept. If you look here, what's this going up by? Plus 4. You see your rate or your slope is 4. So you can see in a table the slope as well. Let's go to the next one. Remember, if you can't get out, hit second, quit. Y equals, let's clear, hit clear. We're just going to do 3x. So what does that do to the line if there's no plus or minus anything? Well, it makes it go through, let's hit trace, 0, 0. So this one's going to go through 0, 0. It is positive, so it's going upward this way. And then let's hit second table to write down some of the ordered pairs. 0, 0, 1, 3, 2, 6, 3, 9. That's good. My y-intercept is always where x is 0, so this here, is my y-intercept. I can tell what the slope is of a line if the x's are going up by 1 by just counting what the rate is in the y column, as long as the x's are going up by 1. And we'll talk about what to do if it doesn't go up by 1s later in the chapter. Hit y equals and clear that out, and this time let's type negative 5x minus 4. So I'm going to hit trace. There we go. It's crossing at 0, negative 4. Do I expect it to cross at 0, negative 4? I do, because I see that I have a negative 4 here for my y-intercept. So let's say that it's somewhere around there. It is negative, so it is going this way. Let's hit second graph for the table. We'll start with 0, negative 4, 1, negative 9, 2, negative 14, then 3, negative 19. All right, again, y-intercept is where x is 0. And if you look at this here, as these are increasing by 1, right? These are going up by 1. These are going up by, or going down by 5. They're going down 5. So the change in the y's over the change in the x's. Rise over run, negative 5. Did I get negative 5 here? Yes. Okay. All right, we're just going to do, type in some equations just to see what they look like. Second quit, go to the y equals, hit clear. So we're going to type in 3x plus 7 and graph it. We're just going to sketch it. All right, so if I hit trace, it's at 0, 7, so it's up here somewhere, way up here. And we're just going to sketch the graph. It is a straight line, okay? Let's go to y equals, hit clear. type in x minus 5. And again, if it's too fast, just hit pause while you're doing it. X minus 5. So if I hit trace, it's at 0, negative 5 down here, and it goes like that. Another straight line. Okay. Y equals, clear it out. Now we're going to type something weird. Because to be linear, we said that the exponents can only have an exponent of 1. This has an exponent of 2. So to get the exponent of 2, hit your x button first, and then there's an x squared button on here. You see it down here on the left side. If you hit that, notice that it gives you a little second power. And then we're going to hit plus 2, and we're going to hit graph and see what that does. Ooh, these are something called quadratic functions, and you will do these next year. If I hit trace, it looks like it crossed at the 0, 2, right there. All right, clear that out. Go to your y equals, clear. We're going to hit 2x, and then that second power button, and then minus 4. Hit graph. Cool. All right, we hit trace. Looks like it crosses at 0, negative 4. So it crosses down here somewhere. That one was a little bit skinnier than the other one. All right, now we're going to try something different. Go to the y equal and hit clear. This time I have an x to the third, so I need my x. But any other power, we have to use that little caret button over here on the left-hand side to get a power. Now it raised it up, and we're going to type in 3. Arrow to the right, so you get out of the power, and hit plus 1. Graph, let's see what a cubed does, a third power does. All right, so if I hit trace, that's at 0, 1, and it looks like it kind of goes up like that. Let's try another third power one. Go to y equals. Actually, I can just do this. Delete, delete, and minus 3. So now I have x to the third minus 3. Hit graph. If I hit trace, it looks like it crosses at negative 3 down here, but it looks the same way. Does the same kind of a graph, a little squiggly line graph. And let's clear that out and type in 5 divided by x. That's what 5 over x is. What's that going to do? Interesting. So notice how that never crosses the x-axis, so because it can never be 0. So we can never have a 0 down here because you can't divide by 0. You can have a 0 on the top, but you can't have a 0 on the bottom. So it's avoiding the axes. It will never touch either axis. And that's it.